In today's tutorial, I'll show you how to connect and configure a Weintek HMI screen and an Omron inverter. We'll also write a simple program to control motor speed. I'll demonstrate how to connect the devices electrically using the 485, configure their communication parameters, and go over the basics of the EBPro software. I'll be using an Omron inverter and a Weintek HMI screen. We'll start with the physical electrical connection between our inverter and the HMI screen. For this, we will need two instructions from the manufacturer, one with the pin outputs for the HMI screen and the other with the instructions for the Omron inverter. I will leave the link to them in the description. I'm opening the instruction manual containing the pin outputs from the manufacturer of the screen, Weintek. I'm looking for my screen model. In my case, I'm looking for the MT8072 IP. After going to the section for my screen model, I'm looking for which output I will need. In my case, it will be COM2 because I will be using two-wire 485 serial communication. I see that I will need pin 1 and pin 2, the first pin for receiving transmission and the second for sending data. Once I know which pins of the screen I will need, I open the second instruction, this time from the inverter, and look for the section dedicated to 485 serial connection. In this instruction, it's chapter 8. I am looking for a diagram provided by the manufacturer for connecting devices. In our case, the HMI screen will act as the master from the manual. We connect the HMI screen accordingly. Pin 1 is connected to the SN terminal on the inverter, and pin 2 is connected to the SP terminal on the inverter. Now I will demonstrate how to connect it physically. I am using an adapter for the screen output, but it doesn't change anything. The pins are numbered on the plug and correspond to those in the socket. I connect pin 2 of the screen to the SP terminal of the inverter, and pin 1 of the screen to the SN terminal of the inverter. After connecting the pins, I plug the adapter into the COM2 port of the screen. With the physical connections complete, we can move on to the second part, configuring the connection parameters in EBPro and setting the corresponding inverter parameters to establish the correct connection type. We open the EBPro software. After launching, we select New Project, choose the model of our HMI screen, in my case, the MT8072 IP, confirm our selection, and click OK. Once the program loads, navigate to the System Parameters section. Here, you'll add a new device. First, I assign a clear name to the device to avoid confusion with other devices in the project. Then select the connection type Modbus RTU with hexadecimal addressing, as specified in the inverter's manual. This approach simplifies setup since the inverter instructions use hex addressing as a standard reference. Next, I configure the screen port I'll be using, set the connection type, and adjust the communication parameters such as boot rate, data bits, parity, and stop bits. These parameters will need to match exactly on the inverter to ensure proper communication. After configuring the screen's communication parameters, it's time to set the same parameters on the inverter. To do this, I return to the inverter manual and look up the section on 485 communication. I look up the parameters that need adjusting to match those on the screen, ensuring the communication settings are aligned for seamless operation. I identify specific parameters, such as boot rate, data bits, parity, and stop bits, and adjust them to match the settings configured on the screen. I compare the parameters on the screen and notice that I need to set 3 parameters of communication. In my case parameters, set Y14 to 2, Y16 to 3, Y11 to 10. This will be the same as on HMI. Parameter Y11 is the unique device ID assigned to each slave device. You can choose this ID freely, as long as it falls within the range of 1 to 255. After configuring the communication settings, it's helpful to immediately look for the parameters that need to be set on the inverter to define the output frequency range. I've checked this in advance, and the relevant parameters are F03, F15, and F16. I navigate through the inverter settings exactly as shown in the video. I start by setting F03 and proceed through each necessary parameter, finishing with Y16. Values of parameters: F03 70.00 Hz, F15 70.00 Hz, F16 0 Hz, Y14 2, Y11 10, Y16 3. With the connection between the devices configured, it's time to write a simple program to control the inverter's output frequency. To control output frequency, we'll need two elements: switch used to activate forward motion on the inverter and numeric that will allow us to enter and adjust the frequency. Let's start with the toggle switch. I selected and click on it to see options. I set the device in which the bit is to be changed and configure the full address. The address consists of the three parts. To change a bit, it must start with 0x followed by the target address. The part before the hashtag represents the slave station address, Y11. We set it to 10, and the part after the hashtag is the memory address of the inverter that we want to modify. To find the specific memory address we want to modify, we refer to the inverter manual. This address will be in the section dedicated to Modbus registers addresses. We need to locate the address responsible for enabling the forward movement. Once found, we see that its hexadecimal address is 0. We need to locate the address responsible for enabling the forward movement. Once found, we see that its hexadecimal address is 0. Now, we need to create a numeric object that will allow us to control the output frequency value for the inverter. To do this, we select the numeric object from the button window. Similarly to the toggle switch, we select the device and configure the address field. We set the command prefix to 6x, which allows us to edit register values. And we specify device address part before hashtag, the same as toggle switch because it is the same device. Then, we return to the inverter manual to locate the Modbus register address responsible for changing the frequency reference. After some searching, we find that this address of frequency reference is 5001 in hexadecimal. We enter this value in the address field after the hashtag. Additionally, we need to adjust the data entry format. We'll be entering numbers in the range from 0 to 20,000, as this is the inverter's resolution range for frequency adjustment. We set the number of digits to 5 and impose a maximum entry limit of 20,000. Once everything is set up, we save our program and compile and prepare to upload it to the HMI screen. To upload program to HMI, the IPv4 address of laptop must be in the same range as the HMI screen, meaning the first 3 segments should match the screens while the last segment must differ. Since the screen's IP in my case is set to 1000,100, we'll choose a unique number, like 1000,198. To accomplish this, we open the control panel, navigate through the network sections, and go to the menu where we can change the IPv4 address for our laptop's LAN adapter. The IPv4 address must be in the same range as the HMI screen, meaning the first 3 segments should match the screens while the last segment must differ. Since the screen's IP in my case is set to 10.00100, we'll choose a unique number, like 1000,198. Continuing with the HMI configuration, we need to set the IP address and screen name. To access settings, tap on the gear icon to open the settings menu. Then enter password. Input the default password, which is 111,111 and OK. We navigate through the screen settings as demonstrated, configuring the IP. The first 3 segments of the IP address match the laptop's IPv4 address. The last segment is unique, differing from the laptop's final segment. Also, you can the desired name for the HMI screen, and then confirm to save all changes. It can be any name, as it's only needed for identification purposes. Final step. Now, let's upload the program to the HMI screen. Connect the HMI screen to the laptop using an Ethernet cable. Select the Download PC HMI option. Click Search All to locate the HMI screen. Look for the screen name you set a moment ago. Once located, proceed with the download to transfer the program to the HMI screen. After the download process is complete, the HMI screen will automatically restart, and our program will appear on the display. This confirms that the program has been successfully uploaded and is ready for use. Let's move on to controlling the inverter. Using the button on the left, you can turn the inverter's drive on or off. Pressing the button activates the forward drive, while pressing it again stops the inverter. The numeric object on the right controls the inverter's output frequency, which effectively sets the motor speed if a motor is connected. By adjusting the value in this field, you can increase or decrease the motor speed directly from the HMI screen. The frequency value we can set on the inverter ranges from 0 to 70 Hz defined by parameters F16 to F03 F15. The inverter register's resolution for frequency control is 20K. This means that in the numeric object, a value of 20K corresponds to the upper frequency limit of 70 Hz, while a value of 0 corresponds to 0 Hz.
That's all for today. Thank you for watching, and I'd also really appreciate any positive feedback, comments and thumbs up go a long way. Don't forget to check out the other videos on this channel.